Angle relationships in quadrilaterals. Just as a reminder, a quadrilateral is a shape that has four sides, and we have two specific angle properties of all quadrilaterals. The sum of the interior angles is 360 degrees, and the sum of the exterior angles is 360 degrees. So we can use these two angle properties to solve for missing angles or unknown angles in any quadrilateral. So example 1, we're going to solve for missing angle D. So we have A, B, C, and D, and we also have here an X kind of indicating angle D as well. So all of these interior angles need to add up to 360 degrees. So we can write it as angle A plus angle B plus angle C plus angle D is equal to 360. Now sometimes your angles aren't going to be labeled at all, you won't need to do this. So A is 56, B is 95, C is 98, and we don't know what angle D is, but we have an X there representing angle D. So now we need to add all of these numbers together, and we're going to get 249 plus X is equal to 360. We want X by itself, so we're going to subtract 249 from 360, and that's going to give us 111. So that tells us that angle D is 111 degrees. In example 2, we're going to use a different property of quadrilaterals, that the exterior angles all add up to 360 degrees. So our exterior angles are indicated right here. We have 50, 88, and 105, and then we are missing this one right here, which is being called Y. So we know that the sum needs to be 360 degrees. So we can do what we did in example 1 if we wish, but you could also think about it in this way, that Y is going to be whatever is left over after we have subtracted all of these other angles from 360 degrees. So we have Y is equal to 360 minus 50 minus 105 minus 88. And that's going to give us 117. So therefore, angle Y is equal to 117 degrees. Next, let's do a quadrilateral where we have a combination of missing interior and exterior angles. And you can see we have A, B, C, D, and E to solve for. We're given one exterior angle of 119 degrees, and we're given two interior angles, 104 and 87 degrees. So what we're going to do here is we're going to start off by using our supplementary angles rule to solve for many of these missing angles. So for example, if we look along here where I just drew the red line, 119 plus A, this should equal 180 degrees. Right? That's what the supplementary angle theorem tells us. Here's another straight line. So 104 plus E should give us 180 degrees. And down here, we have 87 on one side of the line, D on the other. If we add these two together as well, we should also get 180 degrees. Okay, so we're going to solve for all of these using what we know about supplementary angles, or SA for short. So they need to add together to give us 180. So A plus 119 is equal to 180 degrees. And we want to get A by itself. So A is equal to 180 minus 119. And A is equal to 61 degrees. Okay, let's solve for E. So another way to think of this, besides the fact that E plus 104 is equal to 180, we can think of E being equal to 180 minus 104. And E is going to be whatever is left over. So E is going to be 76 degrees. Now let's find D using supplementary angles. So D is going to be equal to 180 minus 87, and D is equal to 93 degrees. So we still have two more to find. We have B and we have C. So let's take a look at C. So C is an interior angle, and now that we found angle A, we have all except for C for the interior angles. So I'm just going to write interior angles here. Okay, so C is going to be equal to 360 minus A, which is 61, minus 104, minus 87. So C is equal to 108 degrees. And lastly, we are going to solve for B. And we can actually now use the supplementary angle theorem to find B because we have C. So B is going to be equal to 180 minus 108. So B is equal to 72 degrees. Let's take a look at parallelograms. So they are special quadrilaterals that share the following properties. So the opposite sides are parallel to each other and the same length. The angles of the opposite vertices are equal. So those are like the opposite corners across from each other. And adjacent angles, so angles that are beside or next to each other, are supplementary. And this means that they add to 180 degrees. So we're going to take a look at our parallelogram below, and we are going to solve for our missing angles A, B, and C based on the given information there from angle D. So we are told that angle D is 50 degrees, and we know that angles of opposite vertices are equal. So this tells us that angle B is also 50 degrees. Now we still have to find angles A and angles C. So adjacent angles, angles that are beside or next to each other, are supplementary, which means they add to 180 degrees. So if we take a look right here, and I'm drawing it in red, we can look at angles D and C. So angle D plus angle C should be equal to 180 degrees. So this gives us 50 plus angle C is 180, and angle C is equal to 180 minus 50. Therefore, angle C is going to be equal to 130 degrees. So I'm going to write that in there. Now, going back to our opposite angles, or so the opposite vertices are the same angle, angle A is also going to be 130 degrees. So we have found angle C, and we've also found angle A, and we've found angle B. Now, another way to think about angles D and C and their relationship is if you think about the co-interior angles when we have parallel lines and a transversal. So PLT/C, so co-interior angles. Nope, that's not how we spell it. Okay, so this can also apply to angles D and C. Lastly, we are going to do an example where we use our knowledge of solving equations to find a missing angle. So in this case, we're going to be looking for angle J. And below you can see we have a quadrilateral with angles at J, M, L, and K. And we only really know one interior angle for certain. We know angle L, and the other angles are represented by an expression. But we know that the interior angles of a quadrilateral all add to 360 degrees. So we are going to add up angle M, L, K, and J and set it equal to 360 degrees. So I'm going to start with angle M. So 5x plus 67, then plus 70, which is angle L, plus 7x minus 6, which is angle K, plus 64 minus x, which is angle J, is all equal to 360 degrees. So we're asked to find angle J, and in order to do that, we need to first solve for x and figure out what x is. So we are going to collect our like terms here. So we have a 5x, a 7x, and a minus x that are like terms. So 5x plus 7x minus x, remember we can treat this as 1x, that's going to give us 11x. And then we have 67, 70, minus 6, and plus 64. Those are also like terms. So we can add all of those together, and that's going to give us 195. So we have simplified our equation, and now we can get on with solving for x. So we want to get x by itself. So we're going to subtract 195 from the right-hand side. And that's going to give us 11x is equal to 165. And now we need to get x by itself. So x is equal to 165 divided by 11. We're doing division on the right-hand side because it's the opposite of multiplication that we have on the left-hand side. And x is equal to 15. So this is not our angle, but it's going to help us to find our angle. So angle J, oops, I wrote over the J. Angle J is equal to 64 minus x. So now we're just going to put in 15 for x and solve for J. And we're going to find that angle J is equal to 49 degrees.